Let's talk about how we show ionic bonding. You need to have a periodic table available in order to tell the number of valence electrons for each. So the first one we're going to do is calcium bonding with fluorine. And you might note that I don't tell you how many calcium and how many fluorine. There's only one way they can go together. So we need to draw the Lewis dot structures for each. Calcium, if we look at it, it is in group 2, so it has 2 valence electrons. Remember, those first two go together. And we have fluorine. And fluorine is in group 17, so it has 7. And you can see pretty quickly that calcium has 2 electrons to get rid of, and fluorine needs 1 more in this empty space here. So we're going to circle the electron that's moving, and we're going to draw an arrow to where it goes. It goes right here. But calcium has 1 more to give away. So we're going to need another fluorine in order to accept that. Because remember that bonding always occurs until everybody has a full outer shell. So they need to either have 8 or none. It goes here. So we end up with a calcium that has a +2 charge because it's lost 2 electrons, and 2 fluorine atoms that have nice full outer shells, and they have -1 charges. And we can write the formula for CaF2. Okay, let's do another example. Let's do potassium and nitrogen. Potassium is in the first group, so it has 1 valence electron. Nitrogen is in group 15, so it has 5. You can pretty quickly see that potassium is going to give this up. We're going to circle it and show an arrow. And now this potassium is happy, but nitrogen needs 2 more. So we're going to need 2 more potassium ions. And all these potassiums end up being +1, and this nitrogen ends up being -3, because they got 3 extra electrons. And we get K3N. Do one more example. Gallium and sulfur. Gallium is Ga. And if you look at your periodic table, Ga is in group 13, so it has 3. And sulfur is in group 16, so it has 6. So gallium is going to give up electrons. Now this sulfur is happy at -2, but gallium still has 1 more electron. So we're going to need 1 more atom to accept electrons. Now this gallium is happy too, and it's +3 now because it got rid of 3 electrons. But the sulfur needs 1 more electron. So we need another gallium. You just keep adding until everybody has full outer shells. Sulfur's good. We need to get rid of 2 more here. So we're going to add 1 more sulfur. So this electron goes here, and this electron goes here, and everybody is happy. So we have Ga2S3. Make sure when you show this, you show arrows and that you're very clearly showing me that the electrons are going somewhere. They're not being shared, they're leaving.